Okay? It's 1,000 Newton meters. Okay, cool. But I really want to know RCY. That's the whole reason I started this. Or RAY, RA. I want to know one of those. So I'm going to bring this equation back. Moment equals force times distance. Right here. Moment C equals distance C times force C. I know moment C, right? That's 1,000 Newton meters. I don't know force C, but actually I'm gonna change the name of that. What does this thing actually call it? RCY. So let's be honest here. We'll call it RCY. So all I need really is distance. How far is RCY from A perpendicular to the force? What?
Well, is it 10?
Yeah, it's 10. It's still perpendicular, even though it's coming up. It's still perpendicular. So yeah, it's still 10. So I'm going to divide both sides by 10 meters. And I'm going to say that RCY is equal to 100 newtons. And that's great, because that breaks us into the problem. It gets us RCY, yes. Now we can do stuff with that number. Yeah.
Can you also just like say, well, 100, it's static, so 100 newtons pushing down would have to be equal to a force pushing up. So the force pushing up is RCY, so RCY would be 100.
Well, in this simple example, yes.
Okay.
But as we start to have other things going on, you'll see in the next example, it may not always be that we have a given force and a reaction force right at the same
Well,
point.
you can't do that. Okay.
Right, right. So, so that's great. I'm going to go ahead and write myself a little scoreboard over here for things I'm going to have to solve. Eventually, I'd like to know how much force is on each member, because that's going to tell me how to build it, right? How strong does it need to be? Does it need to be steel or wood or whatever? So I'm going to say force AB is something I'm going to need to know. I'm going to say force BC is something I'm going to need to know. Force, what am I forgetting?
AC.
AC is something I'm going to need to know. And RAX, RAY, and RCY. Okay? And we already know RCY. I'm going to put that here. Okay? All right. So that's step one. Step one, take a moment. What is the point of taking a moment? To get one of those reaction forces. Just break your way into the problem. Once we've got one, now we're in really good shape. So we go to step two, external forces. And for step two, we're going to minimize here. We're going to think about the truss in a free body diagram perspective. We're going to make the truss like a dot. Okay, there's the truss. Ta-da! So I'm only concerning myself with the external forces. What is physically touching the truss if we imagine it as like a one dot? Okay? What is affecting this truss? What forces are acting on this truss?
The rollers.
So the rollers, yes, we're going to call that a reaction force, right? Because the rollers are supporting it. And what do we call that reaction force?
Normal force.
What do we name it?
Oh, RCY.
RCY. Good. RCY. Okay. And RAY. RAY is also supporting the truss. Good. What else?
Weight.
So when we talk about weight or gravity, okay, normally that's built into our force here. So we say the force is 100 newtons, that's everything. It's the weight, it's everything. Okay? We could, if we're starting to get granular with this and get really specific, then we might start talking about the weight of different members or whatever. But for right now, let's keep it simple. And then just say that's our weight, our force, our everything. What else is active? Well, and by the way, you just said weight, so we should probably write that up here too, right? That 100 newtons. Okay? What else is acting on this truss?
Gravity.
That's in that same 100 newtons.
RAX.
RAX. Okay. 1, 2, 3, 4 things. 1, 2, 3, 4 things. Okay, I think we got it covered. All right. Here, we're going to bring back sum of forces. Sum of forces in the x direction must equal 0. So what is acting in the x direction? You're going to love this. RAX, okay, is it positive or negative?
We said it was positive.
We said it's guessing right now, so we just keep it positive. RAX, okay? What else is acting in the x direction? Nothing. Literally nothing. There's nothing out, right? You don't see any arrows pointing this way. Literally nothing else. So then RAX must equal 0. I told you you're going to like that about statics, right? When things add up to 0, that sometimes makes the math really nice. So RAX is 0. Done. 0 newtons. Awesome. Okay? Okay. Moving on, sum of forces in the y direction. They must equal 0. What is acting in the y direction? 100 newtons. Positive or negative?
Negative.
Why?
It's pointing down.
Because it's pointing down. So we'll say, okay, negative 100 newtons. All right, what else is acting in the y direction?
RCY.
RCY is positive or negative?
Positive.
Positive. Positive. RCY. And RAY, positive or negative?
Positive.
Positive. Because they're both pointing up. I know that all must equal 0. So I'm going to add 100 to get it on the other side. RCY plus RAY equals 100 newtons. And, uh-oh, I'm stuck.
You have you have
I already have RCY. Check my scoreboard. Yeah, I have RCY. Cool. I can sub that in. So RCY is 100 newtons plus RAY must equal 100 newtons. So I'd subtract 100 from each side. And RAY turns out to be what?
0.
0. So a quick sanity check. Let's look at this triangle. The only force on this triangle is right here on this point. So there's actually not any force over here, in here, really in there. It's really just sitting on this point. So it's kind of a useless truss here. Okay? The reason I started with this one is because it was going to be so easy. There's very little going on elsewhere in my problem.
Yeah.
Okay? All right. Questions so far? Yeah.
So would that make f of AB 0?
Yes, it would. But we'll talk about why in our next problem. Okay? Questions on this before we move forward? Okay. So what I'm going to do now, we're not going to follow this problem all the way through because it's not really worth our time because it's super simple. What we're going to do is we're going to change one little thing about this truss, and then we're going to start again. Okay, so make a new spot in your notes, like next problem, whatever. Okay, while I erase here. We're going to repeat step 1 and step 2. And I guess step 0, why not? All right, so here's the change I'm going to make. I'm going to take my 100 Newton force, and instead of it being here, I'm going to put it here. Okay, I'm grabbing this truss, pulling it that way. 100 Newton force. Okay? Now, let's check static determinacy. Did I change the number of joints?
No.
Did I change the number of members?
Nope.
Did I change the number of reaction forces? So is it still statically determinate?
Yeah.
Yeah. Like I didn't change any of the variables here, so it's got to still be statically determined. So we don't really have to do step 0. Okay? But we do need to do step 1. Okay? RAY, RCY, RAX, this all might have changed depending on where I pull this.
Are the supports at the same?
Yeah, these supports are the same. Yep, it was still a roller support, it was still a pin support, so all that is the same. Okay, I didn't move any of that. All right. So, just like before, we're going to take a moment.
Sure.
Okay? And we're going to say, all right, now, what causes it to rotate? Same thing, the force and this reaction force. Okay? So, moment force and moment at C. But I want to double check. I know those have to add to be 0. I want to double check. Moment at force. Is that a positive or a negative moment? Not very confident.
Negative.
Why is it negative?
It's going clockwise.
So it wants to go clockwise. But it's going to the right. Doesn't that mean positive?
Right is wrong.
So be super careful, you guys. I want to point this out because it's so easy to get mixed up here. When we're talking about moments, positive and negative is about clockwise, counterclockwise. When we're talking about external forces, positive and negative is about up, down, right, left. I was backwards. Okay? The coordinate system. So be really careful. Okay, so you're telling me this is negative because it's going clockwise. I buy that. So moment F is going to be a negative moment. RCY, moment C, is that going clockwise or counterclockwise?
Counterclockwise.
Counterclockwise. Push the triangle that way. Counterclockwise. So is that positive or negative?
Positive.
Positive. All right, cool. So that's the same as before. Nothing's changed. What is going to change is our moments now. Okay? So, talking about moment F again. What's the equation for moment?
Force times distance.
Force times distance. Is the force the same?
Yes.
Yeah, that hasn't changed, so that's still going to be 100 newtons. Okay, but distance. It doesn't seem like it's 10 meters away anymore.
Well,
It's like 0 meters away.
no. It's not perpendicular.
Oh, it's not. 0 meters is not perpendicular to this force, is it?
Wait,
No, it
but the
is.
vertical line should be perpendicular.
This is perpendicular. Yeah, this line is perpendicular to that force. It sure is, and we're that far away from A. So I need this distance right here.
Yes,
Some
great.
little angle thing.
So Mr. Crash is a jerk and didn't give you that distance.
Bruh.
So you can either be like, please give me the distance, or
Yes.
you don't need that. You don't need me. Right? You have the tools, you have the talent, you can figure this out, you can figure this distance out because you've got angles, you've got length.